question 11 on 9i, you've got this function here. It says to show that the curve is convex for all x is greater than e to the minus 3 over 2. So you have to, obviously, you know the end game here is to solve this inequality for convex. So in order to do that, we must differentiate and differentiate again. So that in itself is quite a process. We've got product rule required here. These two terms can just differentiate as normal. And so you get dy by dx is this. Okay. Then if you differentiate that, I've got, again, using the product rule for this term. And there we are. You end up, if you work it through, getting the second derivative as 1 add 2/3 ln x. So we're solving 1 add 2/3 ln x. So the important part of this is how to solve inequalities when they're not just quadratics or straight lines. And really the graph is going to be the best way to do this. So we're interested in when 1 add 2/3 ln x is bigger than 0. So we know what ln x looks like, and so these are both transformations of y, so it's shifted up, which would change this point here from 1 to something else, and it's been stretched in the y direction, which won't really impact on your drawing. So here's my sketch for 1 add 2/3 ln x. When is 1 add 2/3 ln x above x-axis? Well, that would be when it's greater than 0, so that's what we're interested in there, and that's this red bit. So clearly we're interested in what this x value is, the root here. So it's the critical value, we'll just solve that. So we can see that x, the critical point of e to the minus 3 over 2, any x values that are bigger than e to the minus 3 over 2 will result in a 1 add 2/3 ln x value that is bigger than 0, and that's what we're being asked to show. So there you go. And that's good. That's good enough. Now, don't worry about the inequality signs. I've already mentioned that they use greater than, less than, and greater than or equal to, and less than or equal to, basically interchangeably here. There's some argument about whether it's one or the other, but it won't matter for you. Okay.